Track and field is the second largest sport on earth, and one of the biggest events is discus. For most throwing athletes, the most tedious part of their sport is retrieving their implements by hand from the sector in between their throws. Because of this manual retrieval, multiple people have been seriously injured after being struck while in the sector. Currently, there are no options available to retrieve implements without having a person in the sector, which increases the risk of future injuries. The sector sweeper aims to fix this problem by allowing retrieval while keeping people out of the sector.
We reached out to over 200 athletes, coaches, and officials to get their thoughts on what they would like to see in a potential product. From the results of the survey, we were able to come up with a list of customer needs. We need to be able to pick up and store at least one discus. The sector sweeper must function on grass terrain. During the retrieval process, we must not harm the user, the implement, or the sector. The battery life must last for at least 30 minutes. The fetching and retrieval process must happen in under 3 minutes with minimal interaction from the user. And finally, we want the sector sweeper to be visually appealing.
Our concept generation phase began with defining a functional decomposition to determine our 5 subsystems: sensing, movement, collection, storage, and removal. Our team members individually generated multiple concepts for each subsystem. After removing the most unfavorable subsystem ideas, we generated 10 full system combinations which were compared using our specifications, allowing us to find the best aspects of each. Using these aspects, we generated 4 additional full system concepts that were also sent through the screening matrix. We scored our 6 most favorable designs and determined we should use remote control and camera for sensing, mechanism wheels for movement, a combine harvester for collection, and hand removal from a truck bed for storage and removal.
Our final system concept that we elected to go for was to have a combination of remote control and using OpenCV with a Raspberry Pi for sensing, lawnmower wheels for movement, a combine harvester for collection, an open truck bed for storage, and the use of the user's hand for our retrieval method. While initially we had chosen mechanism wheels to allow for omnidirectional movement, those were changed to lawnmower wheels due to budgetary constraints. Likewise, we decided to machine the arbors ourselves to save money. The wheels are all independently controlled using DC motors. The control scheme uses skid steering to turn on the grass sector. The collection subsystem initially had an extended ramp that sat in the front of the robot. This was changed to a shorter internal ramp to save space. We determined our optimal ramp angle and height combination after extensive analysis and testing, and opted to go for a 20-degree ramp that is 1.5 inches tall. We transitioned from aluminum to plywood body panels for a lighter and more versatile material.
For all of our subsystems, multiple tests and analyses were completed to ensure the feasibility of our designs. Within the sensing subsystem, we tested the range at which the Raspberry Pi could detect different colors, which allowed us to determine it would be best to paint the discus blue. For the collection subsystem, stress analysis was completed and showed a very high factor of safety on the critical components. For movement, we created Simulink models to examine the dynamics of the sector sweeper in order to select our motors. Finally, in the source subsystem, we calculated an internal ramp angle of 15 degrees would ensure the discus stay inside the bed during transit.
For our final prototype, a woman's discus was placed within the field, after which the sector sweeper was deployed for collection. Multiple trials were conducted at varying approach angles, and while we were unable to achieve our lofty 70% capture rate, our prototype was still able to pick up a discus a modest 50% of the time. Additionally, an emergency stop function was added and tested, fully shutting down the system upon a user input on the controller.
The user will remotely drive the sector sweeper to the discus, at which point our autonomous mode takes over. We can use a Raspberry Pi camera to detect the location of a painted discus using color tracking. The Raspberry Pi then sends that signal to our Arduino Mega, which controls the wheel motors to navigate us to the discus. Once aligned and in range, the collection system starts and we pick up the discus. When the discus has been collected, we switch back to the remote control mode, allowing the user to navigate the sector sweeper back to the throwing circle. If at any point the user feels unsafe or thinks something is wrong, they can press the emergency stop button to shut down the movement of the robot.
Oh, it saw my shoes.